All right. So thank you everybody again for being here. So I'm talking about Jetpack Compose, and my talk is titled Art of the State. So we'll be mainly focusing on state and what's all about it, best practices, etc. So I have seen that we have seen many, we have seen some compose talks by now. So I'll do a quick introduction for the ones that are new to compose, but I'll be doing it fast to not take too much time of my talk on introducing compose, because I think that most of you guys already knows it. So a little bit about me. I'm a senior Android engineer at Citizen. So first, my name, Eury Pérez. I'm from the Dominican Republic. I'm a senior Android engineer at Citizen. I'm a Google developer expert in Android. I have more than 8 years of experience developing Android apps and more than 11 years developing software. I'm a GDG and DevFest Santo Domingo organizer and a servant of Jesus Christ. So, first, let's give a quick Compose intro. So Jetpack Compose is a toolkit to build native UI. So it changes basically the old or the original view system way of constructing UI for a declarative way that is taking the industry for the last years. So let's see imperative versus declarative. What is this about? Let's add some context. So we will be building this simple component. It looks like I don't know, a signature on a blog or something like that. So let's build this simple component. To build it with the view system, which is the original way of building UIs in Android using XML, we need to use, I said it, we need to use an XML tree to define components and its placement. This is the whole code. Don't panic. We'll go chunk by chunk. So first we need to add a container, which in this case is a constraint layout. We have multiple options in Android, but in this example I will be using constraint layout. I'm setting here some properties like the width, the height, background, and padding. So in the first child is the image view, where I set the size, set the source, the drawable that I'm showing, and its placement using the constraints. So, and then I have the first text view, which is for the username. I set the text size, the text style, some margin to separate it from the image, and some information to help place that right to the end of the image, to the top of the to the image, etc. So also we have the headline, which is a subtitle, right? And we add some information as well to help Android, know its size. Since we are using constraint layout, we are knowing the size based on the constraints. So I'm telling Android to take the whole space horizontally, right? So this is pretty much the way where we used to, or where we how we still do it in many applications that are not fully migrated to Compose. So the last step, this is not only thing, we need to go to Java or Kotlin and then have the reference to our views and get our data, and then imperatively, this is where the imperative part comes, imperatively update the properties of our views. In this case, we are setting the text property of the username and headline text views and set it to the specific data, and we are loading the image inside of the image view. So with Compose, we use a different approach, as I mentioned before, which is declarative programming. Declarative means that we have no views references to mutate its properties. So in Compose, we don't have any variable that contains a text view or that contains a button, right? So how it does it? Um, the UI will be composed, right? Constructed, but in this context, we call it composed, based on a provided state. So the state will describe how the UI will look. So a new render of the UI, like the first time you render a UI, is called composition, right? And every update of the UI, every time anything changes and you need to update the UI to reflect the changes, for example, in Facebook or Instagram or LinkedIn, when you click on the like button and it needs to increase the like count and put your name or your profile picture. That will be called a recomposition in the compose context. So we are expanding a little bit more on recomposition later. So to build our component, we need to create a new composable function. So a composable, you can think of, if you're new to compose, you can think of a composable function and compare it like if it's one or more views grouped. Like if it was one XML grouped, that can be expressed as a composable function. For example, well, I'll be giving a more visual example later. So a composable function takes some data and emit UI to be added to the composition. So talk is cheap. Let's see some code and some example. So here is a sample composable function signature. So we need to name the composable functions with the title case. So it's starting with the uppercase. So and we get in the arguments, we get the data that we need to render the composable. So we get, in this case, this is the user info header for the design we saw before. So we get the user info and we get a modifier. So we start by annotating our function with the composable annotation, and adding the arguments we need to build the UI that we desire. So passing a modifier, as you saw, is the best practice. And this is before, I mean, we're not expanding on this. You can check the docs, but a little brief information. So this is because this makes the composable more scalable. Like if you want to change, structural things of your composable, like padding, like some sizing, some placing, you don't need to modify in composables, but instead you can those information through the modifier. So that's why it's recommended to have a modifier in your composables. So the first we need inside of our composable function is a container. So we are using a row because the main organization, or the main placing of the composables are horizontally, right? We have first a profile picture in the left, and then in the right we have first the username in the top, and in the bottom we have some headlines, some subtitle, right? So in this case, we are adding a padding to the whole container to make everything have 15 dps of space in all sides. Um, so, and we have a horizontal arrangement to have all items like horizontal. We have the profile pictures, and then the container that takes that has the two texts. So we will have both of those components spaced by 15 dp. So this is that easy. If you have more components, we all of them will be spaced by the same space. And we tell that all the composables need to be aligned, need to be centered vertically within that container. So when inside of the row, as I mentioned, we will have the image view, or the image composable, sorry, in this case, that will hold the profile picture. So the first we need to do is to set a size to it, right? And then using the painter resource function, we set the drawable, and the content description is mandatory to be specified. We can pass null, but I put profile picture. This is good for accessibility. So that's the first composable that will be showing the profile picture. And um, and differently than with the view system, to make the image circular, here is very easy. In the view system example I had, I mean, the image was originally circular. But here, as you see in the name of the image is drawable, Eury, SQ, or squared. So we just need to add clip to the modifier and pass circle shape, and it will just make it circular for us. So I just wanted to show this quick but simple but powerful function that improves and makes it so simpler than the previous view system in order to make something circular. So at the second child of the row, right, the right part of the row, we will have a column, right? So row arranges items horizontally, right? All the items you place inside of the row will be placed horizontally like a linear layout, right? Like a horizontal linear layout. And the column is it will group the items vertically, right? This is why we have two text views inside of the column, right? With the full name and the headline. So I'm specifying the font size and the font weight. So in Compose, it's a best practice to have everything in themes, right? But for simplicity and for showing the difference between the view system and Compose, I'm doing it in place. But you can go ahead and check the documentation for the theme and how to improve this. Compose those are really good job on this. But this is for the example. So this is the whole code together. You see, it's everything is here, like the UI definition and also setting the values. So we don't need a second file to be linked to the UI definition like in the previous view system. So this is why Compose and the declarative pattern is great. So now that you understand the basics of Compose, let's talk about state. A state is the data that describes the UI, right? Changing the state is the only way we can update the UI. So in our previous example, right, we have a little signature or a little card showing a profile picture, showing the username, and showing some headline. That is a little class, right? That represents the state of the UI. If I change in the state, if I change the full name to be Mahmoud instead of Eury, Compose will reflect that change to update the name. So we will see later how Compose does that in some that we need to take in mind when updating the UI. Compose is smart and only recomposes what really changed. So might have panicked when I said that updating the state is the only way to update the UI, but it doesn't render everything every time. It just takes the state and checks what really different from the last time it composed, and just re-renders those specific part of the UI. So in this case, and the way it detects that is by keeping track of every property of the data passed to the composable. So in this case, you see that we are reading the state in the two text views: user info full name and user info headline, right? So if only full name changed, it won't recompose the second text composable, that way optimizing resources. If I had more composables inside of this user info header, it won't it won't re-renders, it won't recompose any other thing if only full name changed. So that's great too, and save some resources. So to illustrate it, let's use our user info header composable and create a state to hold the user info. So here we are creating a user profile, a screen, right? Inside of that screen, we are using our user info header, right? We are passing some dummy data from a function get user info that will be different in your case. And we can create a state holder using the mutable state of builder function. So as you see, we declare it as a variable, some mutable variable inside of the composable can be, and we use the by delegate, and we use mutable state of, and we need to pass a default value, right? We in this case, we are passing a default value, which is the get user info. So then we can pass the state down to our composable for it to render. But at this point, if you're doing it the same that I have done, you should be seeing a creating a state object without using remember warning. And that's because we are missing a clause or a composable function that will help persist our data over recompositions, which is the remember. If we don't use remember like this, right? We have the same, we just added, we just wrapped the mutable state of creation with the remember um, composable function. If we don't do that, every time our composable recomposes, the state will reset to the initial value. So the changes that you have done to the state won't persist over recompositions. So there's a variation of remember that saves our state on configuration changes, for example, on rotation or when the language of the phone have changed, and it's called remember savable. It's just the same. So when you need to some state to be persisted over configuration changes, instead of using just remember, you can use remember savable, and that's that easy. So learn more about this in the Managing State Docs page. So we can mutate the state by setting the new value. Since we are using delegate, we just set like if we were set the new value directly. If we weren't using delegate, which we had to use state that value equals blah blah blah, like if it was live data. So in this case, we just use state equals to the new data, which is in this case I'm taking the get user info data and just making a copy, right? And just changing what I need to change. Remember that our data class, well, I didn't show it, but our data class is immutable. So all the variables like full name and headline and picture, everything is immutable. So the way I can do to update it is to making a copy like I'm doing here. So making the composable stateless, so make the composable stateless when possible by passing the value and a callback for the events. That's something we are seeing in this example. We are passing to user info header. We are passing, which is the user info, and we're passing also a lambda get the events back. So in this case, in the on click, we are just changing the full name to John Doe. And this is a pattern called state hoisting. Let me explain you about a little bit more about state hoisting. So with the state hoisting, we hoist or lift the state to the composables color. So it's not inside of the composables itself anymore. It's a good practice to have the state in the lowest common ancestor of your composables. So imagine that we have this tree, right? So we have the profile screen, something similar to the example we just saw. And we have inside of the profile screen, we have header, we have latest posts, and we can have maybe two or three more composables inside of that screen. And in this particular example, header and latest posts are using the post composable, right? So, profile screen, if we are talking about the state of the screen, is the lowest common ancestor, right? So the state should be placed inside of the profile screen, right? And then in the header, we pass the data and we send back an event through a lambda, and the same in the other composables. So this pattern is called state hoisting. By making our composable stateless, we make it less error prone and more reusable because the composable is not in charge anymore of updating and storing the state, but just renders based on the information that it gets and just notifies the caller about any event that happened inside of the composable. So the caller handles the state changing or just notify a parent about that event. There's a state that belongs to the UI. Like not all the states should be placed somewhere else. For instance, and some belongs to a specific composable. For example, whether to show a loading spinner. There can be or a section and collapsed state. That's some state that can live inside of a composable. If, as I said before, the state should live in the lowest common ancestor. So if you see that your state is only used on a composable and its children, it doesn't need to be above of that composable in the tree. But what about the data that comes from the API or other external source? Um, when we are integrating Compose or we are migrating to Compose, our domain and data layers architecture can remain the same. We will just be changing the presentation layer basically, and the view models remains almost the same. But I will show you later how to store your state in the view model, which is our next topic: state in the view model. So this is a sample view model, profile view model, right? So we can store the state. We are here storing in a mutable variable with the private set, so we can only mutate inside of the view model and ensure we are hiding the mutability to avoid errors and someone else obtaining a bad state. And then we do the same we did before, using the mutable state of and passing a default value, right? So in this case, we don't need to use remember because the remember, as I mentioned, is used to persist the state across recompositions. So remember that the view models lives longer than the UI life cycle. So with Compose is the same. View model will live longer than the recompositions, than any configuration change that happens. It can destroy the activity, the fragment anyways. So here, you don't need to remember. And then inside of the function, you can get some other information from the API and just update your state. And those changes will be propagated to your composables and update accordingly. So as I said, first we create the state, and this is how we mutate the state. So instead of creating the state holder in the composable, right, like we are doing here, we get it from the view model. So as you see in the user profile screen, I'm getting the view model as an argument, and I'm defaulting the value to use the view model function. The view model function will return the view model of the type specified. In this case, the type specified is profile view model. So we declare the variable of that type. So the first thing to notice that now, as I said, we accept the view model as an argument. We must only pass the view model to the closest composable to the root. So in the root, right, when we say where we say set content, I'm using user profile screen as the container of that screen. So we should only pass view model to that closest to the root composable. Second thing to notice is that now we get the state from the view model and store it in an immutable variable. Last thing is that since the view model is the owner of the state, we don't have the ability to mutate it directly. So to mutate it, we need to call a function on the view model that internally will take care of that as we saw before. Now, let's understand compose stability. I saw one of the last questions of the last talk being related to this, so maybe I will answer the question on that matter. So we briefly defined composition and recomposition before. So let's quickly revisit recomposition and see a new concept called skippability. So this is, I took this from the docs. So recomposition is the process of calling your composable functions again when inputs change. This happens when the function's inputs change. When compose based on new inputs, it only calls the functions or lambdas that might have changed and skips the rest. Right? I put an underline, I made an underline on the skips. So we will be seeing what's about that later. By skipping, all functions or lambdas that don't have changed parameters can recompose efficiently. So if we have like the screen with 5 different children composable inside of it, and only the data that is consumed by the second composable, all the other 4 composable don't need to update or to be recomposed. So that way compose helps, saving resources and don't doing not doing not needed work. Compose only, this is very, very, very important. Compose only skips a composable when the read state is considered stable. What is that? In simple words, that's the state is immutable. Only then compose is sure it won't change without it knowing. Let's see an example. So let's consider this Instagram post from GDG Santo Domingo from the last DevFest as our composable. So let's split it in some sub-composables. So first we have some page branding in the top. We have below we have an image carousel, or it can be one single image anyway. We have then some stats like likes. We have a caption. We have then the comments and the date. But let's focus on the ones that I highlighted. So we will be using these models to hold the state. First, the post class, right? We'll hold a list of URLs for the photos. We'll hold a list of likes. So in this case, I'm not just a number, because as you saw in Instagram, we can see a profile picture. So the like contains the profile picture URL, and yeah. So we also will hold the caption, and we hold the list of comments. And the class that we will actually use as a state, like in the view model when we are creating the state, is this UI state class that will contain a post and a page info. The page info, because remember that in the top of the post, you will see the name of the page and the profile picture of the page, and also in the caption, first you see the name of the page in bold. So this is our post composable example. So we accept a post, a page, and a page info, right? So we render these five other composables, children composables, post header that accepts page info, logo URL, and page post images that will get all the URLs and will take care of showing either a carousel if it's more than one image, or just a single image, and hide the indicator below. The post likes will take care of doing creating that beautiful experience with the likes before below. Sorry, and the post caption will take the page info name as I mentioned before, and show the caption afterwards, and the post comments. So if the user edits the caption like we can do in Instagram, someone comments, or someone like the post, we need to update the UI to reflect those changes. We might be tempted to make the properties mutable. Like in this case, we just make the caption mutable, and we just take the object and we said, okay, post that caption equals to the new caption. But as we saw before, this would make our state unstable, making any composable that reads it unskippable. And that will create performance issues, because if this will always be recomposed, it will be recomposed when it's not needed, and we will be doing work when it's not needed. So after we mutate the caption, this will happen, right? When the post composable is called again, the post header will be skipped, because we are only use the page info there, and the page info object is completely immutable. But post images, post likes, and post comments will be recomposed unnecessarily, because only post that caption, which is only using the post caption composable, changed. So this is the issue that is created if we don't pay attention to the stability. And as I mentioned, only this composable should have recomposed if we had our state immutable. The solution is kind of simple. We is to keep our state stable, aka immutable. There's one last thing that we need to keep in mind. So check out this little class. It's my screen state. You can imagine that it's something similar to the UI state we saw before. So we have three immutable properties: username, which is a string, reactions, which is an int, and posts, which is a list. Would you say this is a stable class? And the answer is no. And that's because list and other collection interfaces are considered unstable by the Compose compiler because classes like mutable list, that are actually mutable, extend from it. So we can end up with this code, which is completely valid, right? And Compose knows it. Compose knows that list and set and other collection interfaces can be can have a value that is mutable. So since this can happen, Compose considers all those interfaces as unstable, making our state, or the composables that use our state unstable to and unskippable. One solution to this is to add this dependency by JetBrains, Kotlin X collections immutable, and use immutable list instead of list, or a similar immutable set, immutable blah blah, from this library, which are considered stable. So to sum it up, first, a state can be created using mutable state of function. Use remember to persist your state across recompositions. Use remember savable to persist your state across configuration changes. Store your state in the lowest common ancestor using the state hoisting pattern. There is more information about this in the managing state docs page, so you can go there and see more examples also in the code labs. Most of the time, it makes sense to store your screen state in the view model, and you don't need to do one or the other. You can do both. Make sure, make sure your state is stable to prevent unnecessary recompositions. So before I continue, there are a couple of tools that we can use. You can look in Google how to know if I mean how to count recompositions. There is a tool in Android Studio Layout Inspector that you can see that works well with Compose. You can see all the times that your composable function was recomposed and all the times that it was skipped. So with that simple tool, you can check if your composable is never skipped. That means that there is an issue there. Also, there is another Gradle tool that will generate like a report with all the composable functions, and next to it, it will put a word like skippable, restartable, blah blah blah. So that's also another tool you can use. So you don't need to. There is a way to be sure that your composables are skippable. So this was it. You can find me in all social media with my name, Eury Pérez. So you can contact me there. And this is QA time. So let's do it.
Yeah, good job, man. That was a very informative session.
Great.
Okay, let's do the Q&A. If you have any question, please leave it now in the Q&A section. So you can start.
Yeah. So can I start reading the Q&A here?
Yeah, can you see it? Can't you see it? It's
Yeah.
in the bar in your right.
Yeah. Yeah. I can see it. So
Okay.
yeah, so I'll go ahead from the top to the bottom. So does modifiers arrangement matters? Why? Yeah, modifiers arrangement matters because Compose will start, how I can say it, like implementing the modifiers properties, right? And for example, if you add a click click listener in a modifier and then add a padding, that can affect the clickable area, right? Because you added a click event first, or a click listener first, and then you added the padding, so modifying the the size. Then where would we put UI logic if not inside composables nor VM? So I don't quite understand the question. If you mean the state, as I said, we can place a state. There's a state that should be there's a state that should be placed inside of a composable, and there is a state that should be placed in the view model. So that depends on your case. And the UI logic, in most of the cases, I have found that the best place to put UI logic is inside of the view model, since it is part of the presentation layer. But yeah, other than that, that's it. Um, so why wouldn't we pass a state class, data class directly to composable instead of passing parameters individually? This was just for the example. You can pass your state, and that will be completely valid. There are cases where you need to pass other values, and that's also valid. Just take care, because the more arguments you have, the more error prone will be your composable. So yeah, this is a great call out. Do you think that passing VMs to composable functions is considered a good practice or not? So according to the documentation, the good practice is to pass the view model only to the closest composable to the root. All composables below to that composable in the tree will need to get the state in some event to let the color composable know about any click or any thing that happened within that composable. So yeah, it's a good pattern, good practice to pass it to the closest to the root, but not to the others. What are those tools again? Specifically, what's the name of the report generating tool? So the report generating tool is not something we install. It's part of Gradle. So I can give me just 1 second. I will paste here. I don't know, Mahmoud, where, well, in the chat I will paste an article where you can find. Yeah, I pasted the article where you can find all those tools, so you can go ahead and check it. What kind of things we might treat them as side effects the best way possible. So as side effects, so yeah, the docs covers that, and also there is a code lab to cover that. So let me think. So let's imagine that we need to call some suspend functions, right, as part of our call, that we generate some, as the name says, some side effects, some data, some anything. So yeah, and the best way, again, the documentation covers it, is to use the launched effect in case it's using a coroutine. There's multiple other ways to handle side effects. I recommend you go to the docs and check every case, because it will depend on every case. How can I test a class for stability? So with the link that I posted in the chat, you can go ahead and check those tools, and it will some one of them, as I said, will give you a report of the stability of every composable, and also you have the inspector in the Android Studio that will count the times that your composable skipped or recomposed. What are the possible ways to detect, find out unnecessary recompositions caused by state variables? So, possible ways to detect, I just mentioned it, that tool in Android Studio that counts recompositions. If you test with that tool and you see that your uh, composable function is never skipped and is always 100% of the time recomposed, then you need to check it out, because something is not going good. Think that was it for the questions.
Yeah. That's a very good advices. We see a lot of abusing Compose.
Yeah.
So, does anyone have any more questions? I think that's it.
Yep.
Yeah. So, nice work, man. Great session. Nice
Yeah,
to have
thank
you.
you. Thank you to the team for for this opportunity, and for and everyone to to listen to this talk.
Okay, thank you. Before we end, we have one last question. Can we have it?
Yeah. So, what do you think about composition local? I think composition local is a great tool. So, do you know that Compose use this? I mean, in the scope, in the context of Compose, we have scopes. So there are functions that can be called only within a specific scope. So, and the way the architects that created Compose created it was to make it scalable and maintainable even by us, the developers. So they didn't want us to have like the composition locals that they created, like the theme one or others. But the fact that we can create our own composition local and have data scoped, it's great. So that's a material for a completely separate talk. So if everyone is interested, I would recommend to go to the docs and check what is that for. For myself, that's a great tool on Compose.
Okay. Thank you, Yuri. Thank you, everyone.